This is gas lab number 1, and this video is designed for students who missed the lab and need to make it up. The question for this lab is, what happens when zinc and hydrogen chloride or hydrochloric acid are combined? Go ahead and write your hypothesis now. For this lab, we're using a number of materials. Zinc metal chips, hydrochloric acid or hydrogen chloride, we're using 20 milliliters of that. Hydrochloric acid that we're using is in this beaker, and I've drawn up 20 milliliters of it in this syringe that we'll be using for the reaction. A bucket of water, or a tub of water rather, 3 Erlenmeyer flasks, a rubber stopper with plastic tubing attached. This is a contraption that we'll use to collect the gas that comes off of the reaction. 2 rubber stoppers. Those rubber stoppers go on the gas collecting flasks. Some wooden splints. Matches, of course, and our match tray we'd use if you were here in the lab. The first part of the lab asks you to make some observations of the zinc and hydrochloric acid as far as color, odor, state of matter, texture, and other observations. Now, in this flask, we have used zinc. Notice that it's a different color than fresh zinc. Fresh zinc is actually gray, silvery gray. So you can make some observations of the fresh zinc. Maybe state that the fresh zinc is silver to gray, whereas the used zinc appears to be black in color. And there's a little bit of water in the flask with the zinc in it. This is where we're going to facilitate our chemical reaction. Odor for zinc. Zinc has no odor. State of matter, obviously, this is solid metal pieces, or zinc turnings is what they're officially called. Texture is probably pretty rough. And then if there are other observations you can make, please write those down under other observations. Hydrochloric acid. Hydrochloric acid is clear, has a very, very strong odor. Some students described it as having a vinegar type smell, but very, very strong, very pungent. And some students described it as smelling like rotten eggs. I, of course, think it smells like a very, very strong vinegar. State of matter is a liquid, obviously. For texture, put Na, not applicable. And if there are other observations about the hydrochloric acid, please write those down now under other observations. Okay, we're going to get started. We're going to collect the gas that's given off by the reaction by water displacement. So we're going to try to collect 2 flasks of gas. So I'm going to go ahead and set it up now. Notice I'm putting 1 flask under water, and the end of the tube that's going to be connected to the gas collecting flask, or the reaction bottle, I'm sorry, is inserted into that flask. Hold on. There we go. All right, so here's our hydrochloric acid. In goes 25 milliliters of that. At this point, you should be making some observations for during the reaction. Okay, so we've now collected 2 samples of the gas. I'll move this out of the way. At this point, you should be making observations of the reaction bottle. Your lab asks you to make some observations of the color of the zinc during the reaction, the temperature. The bottle is actually really warm. So by knowing that the bottle is warm, you should be able to tell me whether this is an endothermic or an exothermic reaction. If you look very closely, you can see some gray pieces that are floating around as the reaction is taking place. There is a precipitate that forms. Maybe a little bit later when the reaction dies down, we'll be able to look back at the bottle and actually see the precipitate floating on the surface of the liquid that's in the flask now. And if there are other observations that you can make, go ahead and make those now under other observations. Actually, now you can kind of see some gray pieces, solid pieces floating on the surface of the water, or the liquid rather, that was not there before. Obviously, this is not pure zinc now. Of course, the zinc is more dense than the liquid and is on bottom, but the precipitate that's now been formed is floating on the surface. Okay, we're going to remove the reaction bottle. Let's now move on to the splint test. We have 2 samples of gas. Turn the lights out. Okay, what we're going to do the same test with both bottles. Basically what I'm going to do is light the wooden splint. I'm going to let it burn for a few seconds so that we get a glowing ember, and then I'm going to blow out the flame, and we're actually going to take that ember and insert it into the flask with the gas. We want to see if the ember goes out, burns brighter, or reignites. Okay, here we go. Okay, here's our flame. Here's our first test. There's going to be a small popping sound. Okay, ember goes in. Okay, notice when the ember goes into the flask with the gas, it goes out. There is a small flame though, notice that's burning at the lip of the flask, and I just used that flame to reignite or relight the splint. I got the ember again, so I'm going to try it one more time. So ember's going in. The ember goes out once it's inside with the gas, but still there's a flame burning at the lip of the flask right now. So one question you might try to answer here is, why is it that there's a flame burning at the lip of the flask, but when the ember is inserted into the flask with the gas, it actually goes out? Let's try it again with the second sample. Here's our second one. I'm lighting the splint again. Okay, you're going to hear a popping sound again, just like before. Okay, so we have a flame at the lip of the flask. You can see that. The ember goes in to the flask and it goes out. But I'm going to relight it with the flame that's burning at the lip. Let's try it one more time. Okay, ember goes in and it goes out. Okay. Okay, at this point you should be able to complete the chart in your lab that says observations during the splint testing, and also complete questions 1 through 5 on the last page of your lab. This concludes Gas Lab number 2.